Tonight we're on a subject of organic evolution has never been observed. All of the haughty bragging about we are people of science, we don't go by faith and all these things is such a foolish concept. They are holding on by faith to something that keeps them from believing that there's a God and that they're going to have to answer to him. That's not acceptable to them. There are two great principles, two great laws, series of laws, and you don't get to be called a law in science until there is never any exception. It is something that is always proven true. The first set are the first and second laws of thermodynamics. We've talked about that a number of times. Thermodynamics is thermo, heat. Dynamics is the energy of heat. And when they were tracing in the industrial age, they were trying to make sure that the energy wasn't leaking off here and there, that they were transferring from the original fire, coal, whatever, making steam, that the energy was continuing on. They were padding these things, keeping the heat in and all this. But they found out that there was no way to perfectly keep that heat. So the second law of thermodynamics is that with every junction of energy turning into some other kind of form of energy, mechanical energy and all this type of stuff, that some heat, some energy was lost. So the general principle, the second law of thermodynamics, is that everything is running down, that everything is it may start out organized, but it is slowly beginning to fall into chaos. The other set of laws is what I want to talk to you about today, and that is our third lesson, Mendel's laws. Mendel is Gregor Johann Mendel, an Austrian-Czech biologist, meteorologist, mathematician, and Augustinian friar. I looked up friar, it means a small chicken. No, that's not that friar. This is a, like Friar Tuck. Anybody know that anymore? Okay. So he was some form of a monk and became an abbot of the St. Thomas Abbey in Brno, which also is Brunn. This is what he looked like, and he only lived 62 years, but he accomplished a great deal. July 20, 1822 to January 6, 1884. He was the first to lay the mathematical foundation of the science of genetics. And I have no idea what that means. I've not studied that at all. But I find it interesting that as a biologist and a mathematician, he was able to do that cross-referencing thing and recognize that there was a clear mathematical structure to genetics. Now, what he was doing is saying, why do 3 children in a family have blonde hair and another 2 have dark hair? What's going on there? What's going on with the change of this? And what he found out is that the genetic structure can get shuffled like cards. It can get mixed up and comes out a little different. But there was a mathematical sequence to it. So Mendel's laws of genetics, with their modern day refinements, because they use this all the time, it explains nearly all physical variations occurring within species. Not just color of hair, but eyes and height and all these things. Mendel discovered that genes, which are the units of heredity, are merely reshuffled from one generation to another. That means they have different combinations are formed, not different genes. Before him, they could assume whatever they want. They just imagined that new genes were popping into existence. He says, no, it's just a reshuffling of the combinations. That's a mathematical concept. So the different combinations produce many variations within each kind of life. As in the dog family, you don't have a recombination where suddenly the dogs are producing cats, you see. You don't have one where they're producing birds. They stay dogs. You can make, breed them to be bigger dogs, smaller dogs, toy dogs, as they say. But you can't breed them to be a llama. It doesn't work. So, now, this is something that was a law, you see. He came up with this, he understood this. A logical consequence of Mendel's laws is that there are limits to such variation. And you can check that in the book Genesis by Strickberger, and page 8, 112. Another man I'll introduce you to here is Alfred Russel Wallace, who independently proposed the theory of organic evolution, or bio evolution of life. He proposed it slightly before Charles Darwin. Darwin was not an inventor in this. He was read this and read that, and did his study and came up with his version of it. But Alfred Russel Wallace, in his opinion, was opposed to Mendel's laws of genetics. Well, be opposed to the law that you can't run through a brick wall without hurting yourself, It doesn't mean you can do it. It's a law. So, Wallace knew that Mendel's experiments showed that the general characteristics of an organism remained within distinct boundaries. Now, what we were laughing about, dogs producing cats or birds or llamas, is ridiculous, you see. Yet that's what evolution says, that they just accidentally, automatically, without any special care, pop into different species. And you see that on your, the monkey turning into the bigger ape and so on, and finally man walking along with a briefcase going to his science class. These are different species. So, if there are limits to what the different combinations can do, evolution can't be true. Evolution says there can be no limit, that the tiny little one-celled animal becomes a multi-celled one, becomes a bigger one, becomes a man. In a letter to Dr. Archibald Reed on December 28, 1909, Wallace wrote, "But on the general relation of Mendelism to evolution, I have come to a very definite conclusion. That is, that it has no relation whatever to the evolution of species or higher groups, but is really antagonistic to such evolution." Now, this is a great, important point, that Mendel's laws are antagonistic to the theory of evolution, you see. If Mendel is correct, evolution is not possible, because Mendel says there's only certain limits. The essential basis, he writes, of evolution, involving as it does the most minute and all-pervading adaptation to the whole environment, adapting to the environment, tiny little changes along the way, is extreme and ever-present plasticity as a condition of survival and adaptation. But the essence of Mendelian characters is their rigidity. They're rigid, not plastic, not plastic in the sense of movable. They say this far and no farther. many, many different variations, but only within the species. So, he says, they are transmitted without variation, therefore, except by the rarest of accidents, can never become adapted to ever-varying conditions. The shuffling of the genetic codes do not necessarily adapt to the environment. Last week, we talked about how God had put within the design of men and animals a switch that if the environment changes to a certain type, it changes the way people or animals are made. The blind fish gained eyes in one generation once they were out of that iodine type of water. Now, it was understood then by an evolutionist that Mendel's laws opposed, that meant that for him to be right, he had to contradict Mendel's laws. But there's still Mendel's laws. It can't be contradicted. Breeding experiments confirm these boundaries. So not only in the theoretical science area, but in breeding animals. Francis Hitching, The Neck of the Giraffe, Where Darwin Went Wrong, page 55. Every series of breeding experiments that has ever taken place has established a finite limit to breeding possibilities. Finite, limited. William Fick's Bone Peddlers, Selling Evolution, pages 184, 185. All competent biologists, he limits it to only competent biologists, acknowledge the limited nature of the variation breeders can produce. Limited nature. Although they do not like to discuss it much when grinding the evolutionary axe. They want to talk about limitations. Evolution is without limitation. A series of books here, Natural Limits to Biological Change, Darwin Retried and Appeal to Reason, Heredity. All of them say essentially this: a rule that all breeders recognize is that there are fixed limits to the amount of change that can be produced. So the squirrel cannot become a bat. All the pictures of how these things happen, they just cannot happen. So, did people like Darwin recognize this? Yes. Common observations also confirm, common observation, breeders, theoretical science, confirm these boundaries. Charles Darwin, Origin of Species, page 322. The distinctions of specific forms, let me back up and give you a picture. If evolution were true, if it were true about our world, we would not go to a zoo and see tigers, lions, elephants. What do you see? Skunks? No, probably not. You would see general four-legged beasts. You see, they would be some form between a lion and an elephant, maybe. Maybe have a bushy tail and a trunk. You would just have this mixture of these things that were just becoming. There would be no definite specificity of species. You wouldn't have lions and tigers and bears. Oh my. So, Darwin says, the distinctions of specific forms and their not being blended together by innumerable transitional links is a very obvious difficulty. Obvious means everybody can see it. It's observed. See? Why are there foxes and wolves and skunks? See? Why isn't it blended in through transitional things? Where is the transition? And finally, Michael Denton, in his book Evolution, A Theory in Crisis, written back in 1985, page 105, indeed the isolation and distinctness of different types of organisms and the existence of clear discontinuities in nature, that things look like this but then they just stop, have been self-evident for centuries, even to non-biologists. We don't expect to see some general four-legged thing, some general winged thing that is a combination of who knows what. See? We see distinct types as God created. Very possibly, in the beginning, God created dogs, and the variations of all the dogs have come about by Mendel's laws. Not that they knew that then, but until Mendel came along. But it followed that pattern, and he recognized the pattern. So, you don't believe in evolution? Well, I have a couple of things that bother me. What's that? The laws of thermodynamics and Mendel's laws. You've heard of those? Both of them prove evolution cannot happen.